Okay. Can see two people joining. Okay. We're behind set schedule, so we can start. I hope you are hearing me. Okay. Can you see the document I shared? Can you see it? Okay. So if you can see the textbook, only that you cannot scroll again. Don't know why. Okay. So if what is not clear, is it my voice or the of okay, if you can hear me, let's see if we can. Basically, the concept of motion has to do with the application of force. If you cannot hear me, you let me know, please. The concept of motion has to do with the application of force that tend to change the position of an object from one point to another. In other words, motion can never be possible without the application of the force. And under motion, no one will ask you to define motion. Simply, they will ask you to maybe uh, solve some problems concerning the equations of motion. And what you are required to do is to be familiar with the equations of motion and some basic concepts like displacement, velocity, acceleration, and so on. So I ask you to come along with the textbook. I'm sure you are with it. I wanted to display it, but it's not very clear. So let's see how far we can go with this. Are you with your textbook there? Are you with your textbook? I see your chat box so that we can respond. Are you with your textbook? I'm waiting for your response. I'm waiting for your response. Are you with your textbook? Can you hear me? If you don't have it, let me know so that I will know what to do. Just respond to the chat box so that, okay, somebody say yes, sir. Okay, yes. Azegeterumo Joseph. Okay, so we want to look at the concepts, distance, and displacement. What is displacement? Displacement is the distance covered in the specified direction. Displacement is the distance covered in the specified direction. As a matter of fact, displacement is a vector quantity. So what really matters here is nobody will ask you to define displacement. No, state the unit of displacement. Already you are supposed to know the unit in case you are asked to calculate. Displacement is measured in meters. So looking at the equations of motion, sometimes you are asked to calculate distance. Okay, I can see you. Okay, you have the textbook here. Okay, so looking at this, the question, like I said, they are not always this difficult questions. What is displacement? Like I defined earlier, the distance covered in the specified direction. What is velocity? The rate of change of displacement. And velocity is measured in meters per second. Then what is acceleration? The rate of change of velocity. Please, you need to be very conversant with these terms because time will come when somebody will talk about, maybe they will sketch something like a displacement time graph. Displacement time graph means you are plotting displacement on the y-axis and time on the x-axis. That is displacement time graph. And when you are describing velocity, you talk about displacement time graph. You need to take note of this. We have what we call displacement time graph. And in displacement time graph, what you are describing is velocity because velocity is displacement over time. Is that right? Then we also have what we call velocity time graph. Velocity time graph. In this case, you are plotting velocity against time. And when you're talking about velocity time graph, what you are describing is uh, acceleration. So when do we say that? When do we talk about uniform velocity and non-uniform velocity? Now, if you plot velocity, displacement against time, you are describing velocity. And if you have a straight line graph, what you are describing, like if you look at page 37, if you have the textbook, if you look at page 37, we're talking about uniform velocity. Can you see it? Page 37, uniform velocity. So if you are there, you can see that there displacement or position is plotted against time. And what you have there is a straight line graph. So question may come, which of these demonstrates or denotes the velocity time graph? That is the uniform velocity. If you are describing uniform velocity, of course, you should have a straight line graph. And if you are describing non-uniform velocity, the the graph will not be uniform. Like in the case of page 38, page 38, you can see that the graph is not a straight line graph. So when you are talking about uniform velocity, we are talking about displacement time graph. Displacement time graph. And then when you are talking about non-uniform velocity, you are still talking about displacement time graph, but in this case, the graph will not be linear. You need to take note of this. And then there's an example there. A man started from a point 45 meters from his house and ran further in the same direction with an average velocity of 15 meters per second for 1 minute. How far is he from his house? Very smart question. Remember, I always tell you when you are given problem always look at the units. You are given displacement is given in meters, velocity is given in meters per second, while time is given in minutes. Something is wrong. Something should tell you that you're supposed to convert something. So in this case, time is given in minutes, which is not an SI unit. So you need to convert time, and then you will calculate. You have this displacement, 45 meters velocity, 15 meters per second at time. So in this case, you now calculate the 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 distance. So please, the technicalities here are that you should know what you are calculating, what you are asked to calculate. It is very, very important. So, and you should know the difference between uniform velocity and non-uniform velocity. Sometimes this thing will be presented graphically, but I told you that for uniform velocity, you have a straight line graph. Non-uniform velocity, the graph will not be straight line graph. It will not be linear. So, and if the graph is not linear, at that point, if you are asked to calculate this, what we call instantaneous velocity. That's the velocity at a point. Instantaneous velocity is the velocity at point. If you look at your figure 3.6 there, that is the point we are talking about instantaneous velocity. That graph being a curve, you cannot take the slope. And you can, if you want to take the slope, you take a slope at a particular point. And that is the point we calculate instantaneous velocity. The velocity at that particular time. The change in displacement over time at that particular point is what we call the instantaneous velocity. Please, if you have any question, you can send it on the chat box so that I can respond to it as we go. So, like I said earlier, if you are describing acceleration graphically, we should talk about velocity time graph. Velocity time graph. And if the graph is linear, we'll talk about uniform acceleration. And if it is not linear, we talk about non-uniform acceleration. And if the rate of change of velocity is increasing with time, we talk about acceleration. But if the rate of change of velocity is decreasing with time, we talk about deceleration or retardation. Graphically, it can be shown that if you have a straight line graph, can you see me on the screen? Can you see me drawing? Okay, it seems you cannot see. So, if the rate of change of velocity with time is increasing with time, we'll talk about acceleration. But if it is decreasing with time, we'll talk about deceleration. So, if you see your figure 3.7, at this point, you can talk about the rate of change of velocity with time is increasing with time. I will talk about uniform acceleration. Excuse me. But if the rate of change, if you look at figure 3.8, if the rate of change is not producing a straight line graph, then we'll talk about non-uniform acceleration. And that is a point you can talk about instantaneous acceleration, the acceleration at that particular point where you have the curve. So if you see page 39, you got 3.8, you can see that. So let's talk about the equations of motion. Like I pointed out, we have basically four, where you say that S is equal to V plus U over 2 times T. You have your pen, you'll be S is equal to V plus U over 2 times T. V stands for the final velocity, U stands for the initial velocity, and time T stands for time. So the total distance covered is the sum of the average velocity times time. You know, when you talk about average, you add them and divide by 2. So starting a body will start moving with an initial velocity and move to a final velocity. So we have two velocities. So by the time you sum them, okay, somebody is asking, why is it that the graph is origin? Okay, maybe you are referring to 3.6. For a non-uniform acceleration, the graph may not start from the origin because the rate of change of velocity with time is not constant. The rate of change of velocity with time is not constant. And that would be the reason why the graph is not starting from the origin. But those ones that have, if the rate of change of velocity or displacement with time is constant, definitely it will start from the origin. Hope that answered your question. So let's move on. So we're talking about equations of motion. Please, we have four equations. The first one, S equal to V plus U over 2 times T. That is the equation to calculate the distance. And we have V equal to U plus AT. V equal to U plus AT. That is the second one. The third one, we have V square equal to U square plus 2AS. I repeat, V square equal to U square plus 2AS. Then we have another one, S equal to UT. S equal to UT plus half AT square. These are the equations of motion. And you are expected to know these equations offhand. And if you are asked to calculate, you first of all write down the parameters. And then ask yourself first. You need to be smart. This parameter, what am I calculating? So which of the equation is applicable? I've solved a lot of problems using Those they are in the video form. You can watch them at your own time. We have a lot of problems I solved in the video form. So what I need to tell you here is that you need to be familiar with these equations. You need to know the parameters given to you, and you need to know what you are supposed to calculate. So if you know this, you now ask yourself, the units given to you, are they in SI units? If they are not, you convert. If they are not, you convert. And then you solve your problem. You need to be smart about it. Like most of the past question, you see a sketch. I've solved also some problems about this sketch, velocity time graph, how to calculate the total distance, displacement time graph, and all these things. Please try to watch those videos and be conversant with those terms. So sometimes a graph will be sketched and then ask you which of these represents the uniform velocity, which of these represent non-uniform velocity, which of these represents. And in the options, you may see a graph talking about, well, I'm talking about velocity, I'm talking about displacement over time. That is what I want you to know. And sometimes one of the options they will write velocity over time. In that case, what we are describing is acceleration. But the question is asking which of these represent a uniform, which of the graph represent a uniform velocity. So note this, when you are talking about velocity time graph, you are describing acceleration. When you are talking about distance time graph, you are talking about what? The displacement time graph, we are talking about velocity. So these are the technicalities. So if you are familiar with this, familiar with the concepts of equations, then you have um, no problem. Know the equations, know the parameters given, know what you are calculating, and then make sure you get your results and the correct units. With this, you will not have issues at all. So the equations of motion, we mentioned them, how to apply them, and there are certain things you need to know. If a question asks, a body starts from rest, you don't need a prophet to tell you that initial velocity is zero. A body is thrown vertically upwards. A body is thrown vertically upwards. At maximum height, final velocity is what? Zero. These are the technicalities. A body, I've solved so many problems regarding this. A body is thrown vertically upwards. You know that. And that body going thrown vertically or is going against gravity. And in that case, the acceleration due to gravity, that is g, will be negative. Anything going against gravity, the value of g must be negative. And at maximum height, v, final velocity, will be 0. And if I say a body is dropped from a height, the body is dropped from a height, the initial velocity is what? 0. You don't need a prophet to tell you this. So these are the technicalities. So, okay, somebody is writing a question here. V is equal to u plus at s. No, that first one is correct. V equal to u plus at, that is 1. S equal to u plus v over 2 times t, not s bracket. Please take note of that. Elisha and O. Please take note of that. V is equal to u plus at. That one is correct. The second equation is S equal to V plus U or U plus V over 2 times T. It should be S equal to. That second equation is not correct. Then the third one is S equal to UT plus half AT squared is correct. And you have V squared equal to U squared plus 2AS, correct. The three of the equations are correct. It's only number 2 that is not correct. S equal to V plus U or U plus V over 2 times T. You say you remember you sent a question earlier. The question is about what? Did you send it on this platform or on the WhatsApp group? Okay, so I was explaining some technicalities involved in solving problems relating to equations of motion. One, body start from rest, u is 0. The body drop from a height, u is 0. A body going against gravity, g is minus. And then a body thrown vertically upward at maximum height, v is equal to 0. I hope you get this because it is very, very important. Then you have talk about the Newton's laws of motion. The first law is also called the law of inertia. The tendency of an object to remain in a state of rest or uniform motion is what we call the inertia. And the first law states that a body will continue in a state of rest or uniform motion unless acted upon by external forces. That is the first law. And that first law is also called the law of inertia. And what is this inertia? The reluctance of the body to stop moving when it is moving, or the reluctance of a body to start moving when it is stationary. That's what we call inertia. So the first law can also be called the law of inertia, Newton's first law of motion. Then the second law of motion states that the rate of change of momentum is directly proportional with the applied force. And what is momentum? Momentum is a product of mass and its velocity. Momentum is a product of mass and its velocity. So, when you talk about the rate of change of momentum, we are talking about the final momentum, the difference between the final momentum, which is mv, minus the initial momentum, which is mu. That's what we call the change in momentum. Mv minus mu, final momentum minus the initial momentum, gives us the change in momentum, which is directly proportional to the applied force. And that second law can be written as F equal to ma. So which of this mathematically represents the Newton's second law of motion? A may be F equal to ma, B may be F equal to m over a, and so on. Those options will be given. So it's good to know this thing. So We also talk about the third law of motion. The third law states that for every action, there must be a reaction in the opposite direction. For every action, there must be a reaction in the opposite direction. For example, if you carry your hand and hit on the wall, that hand you are hitting on the wall is an action, and the wall will also react. And that's the reason why you feel the pain. For every action, there must be a reaction in the opposite direction. So these are the laws of motion. We have three of them: Newton's first law, Newton's second law, Newton's third law of motion. So to recap, you should be conversant with the parameters defining the equations of motion. Displacement is a vector or scalar quantity. It's a vector quantity. What is the unit of displacement? Meters. What is velocity? Rate of change of displacement, that is displacement over time. And what is the unit of this velocity? Meters per second. So if one is describing velocity, what are the parameters that we should look out for? Displacement and time. That is when we talk about displacement time graph. Displacement time graph. Okay, so we're hearing you. I'm aware. So displacement time graph, we are talking about describing a velocity. And when do we talk about uniform velocity? I'm repeating this thing because they're important. When do we talk about uniform velocity? When the graph of displacement plotted against time is a linear graph, then we'll talk about uniform velocity. And if the graph plotted is not a straight line graph, we'll talk about non-uniform velocity. And that is the point one should be talking about: instantaneous velocity. Instantaneous velocity. Then when you talk about velocity, rate of change of velocity with respect to time, we're describing acceleration. What is the unit of acceleration? Meters per second square. What is the unit of acceleration? Meters per second square. And if the rate of change of displacement, if the rate of change of velocity with time is constant, is increasing with time, we talk about acceleration. And if the rate of change of velocity with time is decreasing with time, we talk about retardation or deceleration. So these are the concepts, and you should get familiar with this concept. So please go to the YouTube channel, watch those calculations, and try to look at the past questions as concerns motion. And if you are not able to solve those questions, drop them on the platform, on the WhatsApp platform. I'll put you through. Please, this is the time for revision. Once once the once the timetable is out, you will not have time again. That's the reason why I chose to to do this, but many people are not interested. A class of over 1,000 will have only 5 people joining the this thing. It shows that you guys, many people are not interested, and they are not serious about the whole thing. But I'll keep on doing my best for those that are interested. Maybe by the time you write the exams, you 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 now start saying, "Had I known?" So let's keep on doing it. So we'll maybe by Tuesday we'll have another one, because this week we'll have our lectures. By Thursday, the other week we'll be rounding up for the whole program, for the whole for the semester, preparing for the exams. So maybe on Tuesday we'll have another class. So if there's no question, we'll end the class for now. Thank you.